Hello, and welcome to this pre-recorded edition of physics class. Both classes this week will be in the pre-recorded format due to a family emergency. I will try to keep things as similar as possible to our live classes in terms of the slides and what you're used to seeing, but we'll definitely cut down on the length. So let's move ahead here. So in terms of the schedule, we're going to discuss the elevator lab quiz, briefly give you an update on that, the upcoming coefficient of friction quiz, and then we'll focus on this week's material, which is the drag force. So I'll talk briefly about the drag force and then have introduce you to the activity that you're going to do, quote unquote, during class today. It's due at the end of the day on Wednesday. And then also a reminder that the WebAssign is due tonight. This is the WebAssign from last week that you got an extension on. Looking ahead, Thursday, Friday, there'll be another recorded edition like this. There'll be an Edpuzzle due, drag force, and you're going to start your drag force lab, which is in Excel. And then finally next week, we hope to return to our quote-unquote normal schedule. That would be meeting on Mondays and Wednesdays for second and third period, and Tuesdays and Thursdays for fourth and fifth periods. All right, elevator lab quiz. Most of you finished, a few of you didn't. And unfortunately, I'm still grading because of this family emergency that came up. I'm working my way through it. I think I just have one period graded, unfortunately. There are too many people and remember, I've only looked at a fraction of the quizzes. People that forgot to upload different types of work. I may be contacting you for some work, but you have a very limited time to upload it. And I believe that you get Canvas notifications when the grading is done. If not, you can just look in RedWeb. All right, let's take a look at our next quiz. The only thing, I just want to introduce you to the quiz at this point and give you an idea of what you're going to be doing in it. You actually have to do some legwork. You're kind of preparing the quiz, in fact, on your own. So we're going to use Pivot for this next quiz. It won't happen until next week. It's going to be a lab-focused quiz, right? In other words, it's going to be very similar to the coefficient of friction lab that you did of the man sliding on the ice rink. But this time, you're providing the video, as you can see here in the Pivot screenshot. So what you're going to do is you're going to record video of an object sliding to rest, okay? So this time, you're going to provide the video rather than Pivot, okay? In the lab, they have some video guidelines. I haven't posted the lab for you guys to see yet, so I'm just going to show you those video guidelines now. You already know how to make a video for video analysis purposes, right? You have to have a ruler in there. You have to be head on, okay? And that's what this is talking about. Hold the camera perpendicular. Make sure there's an object of known size. And then if you would make a brief appearance in the video, right, either at the beginning or the end, so that I can know that it's you that made the video. So you want to be working on that. I've assigned that sort of just to fit it somewhere. I've assigned it to be over the weekend, okay? But you can be doing that anytime between now and next week. And then next week we'll actually assign the quiz. All right, let's get to the drag force. So the drag force is a unique force from the other ones, okay, from normal and friction and tension and drag, or excuse me, normal, friction, tension, and weight. And you'll see why in a minute. So before we do so, let's set the baseline. What do we expect? What kind of motion graphs do we expect for an object that is experiencing constant acceleration? Okay, and let's just say that it's speeding up in a positive direction. So think for a moment what you think those graphs would look like. Position time graph, velocity time graph, acceleration time graph. Okay, hopefully this is no surprise here, right? We have on the position time graph a parabola. On the velocity time graph, a slanted line, right? A line of non-zero slope. And then the acceleration time graph is a flat line, either positive or negative. In this case, since we said speeding up in the positive direction, that would be positive acceleration. So here is the tricky thing about the drag force. The drag force is what we call velocity dependent, okay? In other words, as you change your speed, the value of the drag force changes. And what that leads to is a constant change in the net force. And if the net force is changing, then we have changing acceleration. We no longer have constant acceleration, okay? Which means that we would expect a change in the types of graphs that we would expect when we're looking at an object that's experiencing a significant amount of drag force. And that's kind of what we want to do today. We want to explore the types of graphs that we'll get when we have an object experiencing a drag force. All right, let's keep going here. Let me introduce the data logging activity. It's pretty short, okay? Remember that you can get to all your resources on Canvas by just simply going to the home screen. Every once in a while you have to go to the module screen. But if you go to the home screen this week, you're going to see this link right here, okay? And that describes the data logging activity, which I'll describe briefly here, and then I'll actually navigate to Canvas and show it to you again. So basically what you're going to do is you're going to watch a short YouTube video, and you're going to record the velocity and altitude data for 5 or 6 points. Remember, we did this with the Falcon Heavy lab back in the fall. It's the same idea, except it's a person who's skydiving, right? So the most common example of the drag force is air resistance, and objects falling through the air is an example of objects that experience drag force. So you're going to log 5 or 6 data points, all right, and record the data in a shared Google spreadsheet, which I'll show you in a minute. And then you want to take a look at the resulting graphs, right? How are these graphs different when you fall in the presence of a drag force versus in the absence, right? When we just have constant accelerated motion. And after you've done that, okay, that will take you to the end of today's class basically. And then for Thursday, you'd want to do the Edpuzzle, Intro to Drag Force. So it'll be about 5 minutes. And you can get to that through your usual means. Okay, that's what I've listed for the homework for the end of class today and do at the beginning of class Thursday. Let's take a look now at your screen here. Okay, so I'm going to, this would be your screen, your view from Canvas. So I'm going to go now to this link. I'm going to click on it. Okay, the introduction I've basically covered already. Here's the link to the video. The challenge here is that the video is pretty quick, so you have to advance frame by frame. So by using the period and the comma button, you can go forward or backward by frames. Okay. You see the link here to the data logging spreadsheet. I'm going to click on it now. Actually, I've already opened it. So I'm going to just navigate here. And you see across the bottom the different tabs. So make sure that you go to the tab appropriate to your class. And I've already loaded your name. So here, second period. And I've just gone in alphabetical order, right? So Jenna is responsible for these, looks like 5. Looks like I've given everybody 5 data points, right? So you just have to go to that part of the video, right? But you have to make sure you're exactly on the right frame. So you have to go frame by frame until the timer on the bottom turns to 2 seconds, okay? And then you'll record your 5 sets of data here. And once that gets done, right, so probably you won't be doing it at the same time as everybody else, right? I had designed this originally to be done in class, so it would happen in real time. And what will happen is these numbers will fill up, right? It'll automatically be converted to these numbers over here, right? I've converted to metric units, and I converted the altitude to distance fallen. So in other words, this makes down positive. So, and then what ends up happening is if you look over here, okay, I've already created 2 graphs. These graphs will begin to change as people's data populates. So before you watch the drag force Edpuzzle, you're going to want to take a look at what these graphs ended up like. And hopefully people have not let you down in your class and they have filled out their data by the end of the day Wednesday. Okay, just to wrap up, I'll go back to the Canvas screen here, the home screen. Today's activity, again, well, just to review here, WebAssign due tonight, midnight, Tuesday. Today's class activity, right, which we would have done in class anyway had I been with you, is right here. You're going to fill your information out in this data sheet, take a look at graphs when you're done, and then do the Edpuzzle for Thursday. All right, we'll see you soon.